So it's a maximum question, right? So don't take shortcuts at this point. I want to find stationary points. So I should say for stationary points. Or really you could say for turning points, but anyway, potential turning points. For stationary points, my derivative will be equal to 0. Okay? Now, I'm just going to skip a step, but I'm going to tell you what it is. So you shouldn't, but it's just so that I don't have to write so much because it takes me forever up here. Because what I want is the whole derivative should be 0, right? As Richard was mentioning, there's no value I can put in the denominator that's going to make it equal to 0, right? So I don't care what the denominator is, so long as the numerator is 0, and then the denominator can be whatever it likes. So it's really just this part that I'm interested in, okay? That's my numerator, okay? So for that to be 0, I'm going to get this. Okay, now, I'm going to get onto that in a second. But before I do that, I think I'll try a couple of other wiping markers, see if they work better. I don't need that. Now, here's where we got in trouble, right? At this point, you think, two problems. Number one, x to the 4, really? Gross. You start to think, okay, I could do like a let u equal x squared, make that substitution. Then this will turn into a u, this will turn into a u squared, and then it'll sort of be a quadratic. But you still end up having this other huge problem of division and this square root. That's awful, okay? That's really hard to solve. The way that you get rid of it is going to be really, really decisive. It's going to tell you whether you get the answer in like 8 lines or in like 18 lines, okay? So here's what I'm going to suggest. And I'm going to start, well, let me try this one. I'm going to kick this x squared over the other side, okay? So I'm going to get 2, yeah, that's much better. 2x to the 4. I'm not going to do the substitution because I don't feel it actually, after giving it a go, it doesn't make it a whole lot simpler. Just the numbers are slightly smaller. Now, what could I do here, right? To get rid of the fraction, one thing I could do is multiply through by the denominator, okay? And that would make some things better, right? For one, it would get rid of this fraction. For two, it would get rid of this being the square root, okay? So that's good, okay? But there's a problem, right? What's the problem with multiplying through by the square root? Specifically, which part of the numerator? This guy, right? Because this will get simpler, and then the square root just goes over here. Now you're like, 1 square root's better than 2. That's true, but you're basically back where you started. Okay, you still got this enormous radical sign, and it's hard to get rid of. Okay, yeah.
Can't you just times like the denominator and put everything over with x to the power 4 plus 8?
Multiply this denominator here by what? By what?
No, times that into the other one.
Here.
Yeah.
Yeah, okay, I can.
Yeah.
You mean put these on a common denominator?
Yeah.
That'll be fine, but I still will not get rid of my square root sign. It'll still be sitting there on the denominator. It's going to sit somewhere, is my point.
No, I think you can.
Now, here's the tricky thing, okay? And I think this is what you're missing, which is why the answer eluded you. Multiplying through isn't the answer. And this actually comes up in some locus questions as well. Even though it's a bit counterintuitive, what you really need to do at this point, and this is why I moved the x squared over on this side, is you need to square everything. Everything, okay? Now, you usually think that's a bad idea in this case, okay? Because squaring the right-hand side, no big deal. Square the left-hand side, you know?
Multiply through and then
What? Okay, now, if I'm, okay, you're doing twice as much work to get the same result at the end. It's just going to have higher powers, that's all, okay? The reason why is there's something important about these two things that when I put them together. Yeah, there's, well, it's on the denominator, it's on the numerator. That's important because think about what happens, okay? Let's square this out. Let's do it. When I square a plus b all squared, right? What's that equal to? A squared plus 2ab plus b squared. Okay? So think about this with me. Here's my a, so let's square it, the whole lot. Okay, so what happens? you get 4x to the 8. Okay, I know that looks bad. Be patient with it, okay? It's sort of like you're introducing this problem, but you're going to get rid of a bigger one. Okay, so it's like a trade, sort of. What happens to the denominator? Well, the square root sign just disappears. So, voila. Okay, so there's my a squared. Now, what happens to the 2ab? Now, this is really good for us, right? Because when I multiply these two together, the square root just disappears, okay? So I'm going to multiply them together and double, yeah? So I'll get minus 4x to the 4, okay? Yeah, all the other things have come out in the wash. And then lastly, I've got a plus b squared, so I'll square it, and that's what I get. Okay, is that all right? And what happens to the right-hand side? Well, minus, that's going to disappear. That's just an x to the 4. Okay, so that looks a little more workable. I know there's that 8, okay, but at least there's no square root signs. And importantly, even though there's an 8, there are 4s here. It's all even powers. This is kind of like an equation reducible to a quadratic still. Okay. Okay. Now, as it turns out, I don't actually need to do much like fancy footwork. If I just multiply out and simplify, this 4x to the 8 will disappear. Okay, but stay with me. So let's see here. Before I multiply through, I'll simplify a little bit. So I've got 4x to the 8 on this guy. What have I got here? Minus 4x to the 4. This x to the 4 and this x to the 4 should cancel, right? Yeah. So minus 4x to the 4 plus 81. Okay. Now multiply through. So what have I got here? I'm going to put this all together. Is that okay? Yes? Now, no, that looks terrible too, but it's terrible in exactly the right way that we need. Can you see why? Right? Because that x to the 4 and that minus x to the 4, that's going to be the x to the 8 that I needed, right? So 4x to the 8 out the front, but this by this, minus 4x to the 8, this by that, 324, and I don't know what 81 squared is, but someone can tell me. Okay, it's some number. Okay, now, cancel. That's a relief.
1,561.
Thank you. 81 minus 324. They're all multiples of, this is minus 243. Plus. Is that okay? So this is starting to look a little more manageable. And these are all divisible by, yeah, okay, so I'm pretty sure this is where it turns out. I'm pretty sure that's where it goes through. And divide it through. Okay. Because I remember I looked at the answer, this is how you get there, no? Okay. So it's the 4th root of 27. What a terrible number. But then again, we shouldn't be surprised that it should be so weird. Like, for number 1, the 4th root is because there's a 4. That's why. Okay. No, that's the cube root. Q1 is the 4th root. But from there, I think you can handle it, right? You can test on either side. I guess we wouldn't want to use the second derivative, but I think you know what to do. Okay? Yeah. Yes. Good question. You're right. It is plus or minus, but then, because from memory, I think x is a length in this case, or something like that, right? So I can exclude the negative result. Though you're right to mention it, like I should have mentioned it too, and then say it's only the positive one because of this reason. Okay. Ta-da! Okay. So, what's the moral of the story? A couple of things. Be careful with your algebra. You'd be so frustrated if you were going through all of this work and it was just your derivative that you got wrong. That would be really frustrating. And it's not an easy derivative to get. Secondly, when you see all of these square roots and that kind of thing, okay, you've got to know there's more than one way to get rid of them, right? And squaring out, even though usually it's sort of counterintuitive, It's just the kind of twist you would expect for a final question in an exam. Okay.